Welcome and thank you for joining us for today's Toradex webinar. We are going to explore Android for embedded devices and see how you can speed up your product prototyping with the Kynetics Embedded Android Developer Toolkit. My name is Carlos Gonzalez and I lead partnerships and developer experience at Toradex. And I am very pleased to introduce our speaker today. So his name is Diego Rondini. He's a principal embedded engineer with over 15 years at Kynetics, which is a Toradex partner since 2016. So we really go back in time. But before we jump in, just a few quick notes. If you encounter any technical issues, please use the chat window to let us know. You can submit questions throughout the webinar at any point, and we'll address them during the Q&A session at the end. A recording will be available afterwards for on-demand viewing. And with this, we'll get started. So here's what you can expect today. I'll just begin with a very short overview of Toradex and how we support Android in our ecosystem. Then Kynetics will outline when embedded Android is a good option for your project and when it might not be the right choice. Diego will introduce the embedded Android developer kit and the Toradex hardware that it supports. He will also walk us through a short demo of the developer experience and explain the broader Android product lifecycle and show where this developer kit fits in. Finally, we will open the floor for your questions. So let's have a very quick look at Toradex. I think most of you will probably already know about Toradex, but we just put it in the context of Android and specifically about an embedded Android. So Toradex is a Swiss company. We are specialized in embedded computing. We provide ARM-based system of modules designed for reliability, long-term maintenance, and industrial temperature ranges. One of the advantages overall of the SOMs is the faster time to market compared to chip-down designs. And alongside our SOMs, we offer industrial-grade single-board computers with openly available design files, allowing developers to customize them. For those who need tailored solutions, we also offer build carry boards, volume manufacturing, and even we produce enclosures and complete end product builds. So essentially, we have you covered from the beginning till the end. All of our products come with an embedded Linux reference image and also with Torizon, which is a Yocto-based IoT platform. But as you will see today, we also support other operating systems, including Android, specifically through our partner ecosystem. So just going a bit deeper into the operating systems. So Toradex offers free OS support for embedded Linux, as well as for Windows Embedded Compact on some select legacy products. Support for other operating systems like FreeRTOS, Sapphire, and are also available, but not maintained by Toradex. And other commercial and third-party operating systems like QNX, VxWorks, BikeOS, Integrity are provided by our trusted network of third-party partners. Android specifically is not provided by Toradex directly. Instead, Toradex partners with industry leaders like Kynetics provide a very excellent Android offering for these system of modules. And Kynetics in particular have been supporting the full range of products in the Toradex families for the last 10 years or so. So maybe just a very quick overview of our system of module lineup. And I think this is useful when Diego will tell us about the developer kit, so you can basically map out where this kit is available. So we offer 5 SOM families. Within these families, the modules are pin compatible, allowing you to seamlessly scale depending on your needs. Essentially, you can go all the way from M62 to our M69 or the i.MX 95 with an XP or TI. So with that, let's take a closer look at the Kynetics developer kit and how they can make it easier for you to run Android on your Toradex hardware. So Diego, over to you. Please tell us a bit more about your new kit.
Again, Thanks, Carlos, for introducing me. Let me introduce a bit Kynetics. Kynetics started in 2012 as a global provider of Android embedded operating systems for different industries like biotech, diagnostic systems, lab equipment, payment systems, and other kind of embedded devices. You already mentioned, Carlos, since 2016, Kynetics is a Toradex preferred partners for Android projects. But another important aspect is that we are active open source contributors in the embedded software community. In particular, we are very proud to be part of the Eclipse Foundation. And as part of the Eclipse Foundation, we are the main developers of the Eclipse Hara project, which is a open source project to speed up the development of software clients for connecting to Eclipse Cockpit, which is a project to manage software updates on the cloud. Kynetics has headquarters in the USA, Santa Clara, California, but we also have a branch office in Europe, specifically in Padua, in Italy. Let's start having a look at why people developing companies should select Android as a solution for their embedded product. I think the most important aspect is the UI and multimedia. When you develop a product, you want something that is nice to the end user. So we can think of all the good applications that are developed for Android smartphones. You can have pretty much the same great user experience when developing an application for an embedded Android device. That's probably the first thing that comes to mind. The second aspect is a great SDK. The Android SDK APIs cover pretty much everything that is needed to develop an application. So with a single set of APIs, you are ready to develop a full application. So everything is provided as code in a single SDK. There's good hardware support. There's an option for automotive devices. So if you're developing an infotainment system, you can start from the same Android code base and build the automotive flavor. Another important aspect, especially for embedded devices, is the security implementation. Android is literally the operating system for billions of devices. We just need to think of the number of Android smartphones that are available on the market. The security implementation in Android is really strong. Another strong point is that it can be customized. So if the kind of security that a product needs is not aligned with the one provided by a smartphone, it can be configured. So some parts can disable, for example, during the development phase, if security gets in the way, to be enabled later to deliver a secure product. Another important aspect is that there is domain separation between what is part of AOSP and what is provided in terms of building your operating system by the chip makers and the ODM. So there's kind of a reference implementation in AOSP, but then chip makers provide their separate package that is not tightly coupled. So you can end up using one previous version of the drivers and the libraries to support a specific SoC, provided, for example, by NXP or by Texas Instrument, but also update to a newer version of user space. So, for example, using the latest and greatest Android leverage mechanism, like the use of GSI, which is actually to be able to use the latest version of Android, even with old driver, let's say. Last but not least, there's a flexible build system that allows to easily create different variants of an Android build. So if you have two similar products or two variants of the same product, you can project that as part of the build system, so you can build the two flavors from the same source code. There may be reasons why you do not want to use Android. The main example is headless devices. Android is not really a good choice in that case because it has a lot of complexity, a lot of burden, requires a lot of resources. You may have to pick some other option in that case. So now I'm going to ask you to express a choice. So now the poll is open. Please vote. Why would you like to adopt an embedded Android operating system? I already mentioned the great UI experience, but you may also want, I don't know, a marketplace in your embedded device. You may prefer Android because, it provides automotive option or a great security implementation. The last point, we will talk that later, but there are really many Android developers out there, so that will help when you want to create your product. Hiring and Android developers is something that is more easy than.
So maybe, Diego, a quick one. I saw that about 14% of the people wanted to get access to the Google Marketplace. Is that possible with an embedded Android? Can you get access to Pay?
Yes and no. That was kind of a
tricky question.
Option. Yes, because you can do that, but there are certifications involved. So you need to get your device GMS certified. So maybe alternative marketplaces maybe an option in this case, or if you have the scale to do that, you can go with a GMS certification path. But I would say many customers don't start with that. Even, as you said, there's a percentage of users that like that. Okay, so let's have a look at the important aspects when developing a product. I would say that the user experience is what really matters. And the design of your application, the development of your application is really important. I already mentioned having the developers able to create your application as fast as possible is important, because you can get a proof of concept ready in a short time and also have a nice product. You can use AI tools. Again, going back Android has great developer tools. Android Studio is one of those, the SDK, but there are many AI tools nowadays that help writing code faster. Now comes the question, if I want to create an embedded Android product, is that different to developing, I would say, Play Store Android application? Well, there are some differences, but it shouldn't be very different. That's one of the reasons that we decided. That's one of the reasons that brought us to developing the embedded Android developer toolkit. The EADT, how we call it, is a managed solution that bundles an Android operating system and an Android embedded SDK and over-the-air update capabilities. So what is missing when you have an evaluation Android operating system? Well, the first thing that I think of is that, yes, the Android SDK is great, but what if I have to interface with low-level hardware, like, for example, GPIO, I2C, Canvas, or a serial port? That doesn't come as a standard, so you need to be able to add that part of the development to your flow. So the EADT is that bundle of an operating system and an embedded SDK that goes to the specific hardware kit. In the example here, we will show the Toradex SMARC i.MX 95 development kit running the EADT. And at that point, you don't need to worry about the Android internals or applying over-the-air updates, because that's part of the offering. So now we will show you a bit how to install and use the EADT. So you will also learn what is part of the EADT. Okay, so we will go quickly through the installation phase. So once you have your hardware kit, for example, a Toradex i.MX 95 SMARC, we then provide you with the EADT installer, which basically a software running on Linux, on Windows, that will install the Android operating system to your target device. It's available for Linux and Windows, and for selected hardware. Once you put your board in recovery and complete the installation, your device will be running the Kynetics Android, and you will be presented with a device setup screen where you need to provide the tenant, which is the organization name, and the token to connect your device to the Update Factory platform. So you will also get credentials for Update Factory, which is our remote update management platform. So a cloud where you will see all your devices and your updates, and you can manage, in this case, the activation of your devices. So to grab the token, go in the system config page, copy the token, and enter that in the EADT setup page. Once you do that, your device will be connected to Update Factory, and you now need to proceed with the activation. The activation is really simple. We will provide an activation package that you will just need to drag and drop to your device. So you will see your device in the targets list in the deployment page. Just drag and drop the activation package, to your device, and in a few seconds, your device will be activated. So you have your developer license ready, and you will also have access to the SDK example applications. So I mentioned before, there are SDK libraries that can be used to access GPIOs, PWMs, I2C, serial ports. Those libraries are covered in our website in the embedded SDK section. We have many articles in the technical notes website that describe precisely what you need to do to set up your kit to interface. For example, this article is about using the canvas on your device. Because then these libraries will be part of your toolkit. You will be able to integrate those libraries in your application seamlessly, because we provide a Maven repository. You just need to add the library in your build Gradle configuration, and then you're ready to write an application that accesses those low-level buses. In particular, here we are showing an application built to monitor the state of a GPIO. In particular, the developer here has built the application and is going to upload that application in Update Factory. Update Factory has two main concepts when it comes to describing software updates. The first one is a software module. Software module is a set of artifacts. In this case, it's an APK, so what is produced by Android Studio after building your application. You just need to drag and drop your APK to the software module to have your software module ready. Now, when you have to apply that software module to a target, you actually need to create a distribution, because a distribution is a combination of one or more software modules. So an example of a software module could be an OS combined with some applications. So you can, for example, update your Android operating system and a specific application all in one shot, just by combining two different software modules. Now we're showing here how to do the process manually, but this part of the flow can also be automated directly in Android Studio. Okay, now we have our GPIO application ready. We drag and drop that to our target device, which has the EADT, and soon the device will be installed. I get confirmation that I want to install that application on my device. Once the process is complete, I have access to the GPIO application on the device. Of course, remember that when you do an installation through Update Factory, you also get feedback from the device itself, so you know whether the installation completed successfully, whether there was an error and which kind of error. So you know, if you think of a fleet of devices, you know if something is going wrong or at which stage of the rollout the deployment is. So here we're going to show how this application works. It's a very simple example where you monitor the state of a GPIO, but it shows that it's very easy to write such an application. So it complements what the Android SDK provides with the ability to interface with low-level interfaces. Last but not least, we mentioned that the EADT comes with software updates support. In this case, we are installing a security update for our Android OS on the Toradex i.MX 95 device. So as soon as the device is rebooted, we will have the latest and greatest operating system provided by Kynetics installed. In this case, for example, it was a security update that we provided as part of the EADT license. So now we have explained the pieces that are part of the EADT. We will have a look at how this fits. So how this process helps developing embedded Android devices. Let me switch back to the slides.
That was a very nice demo.
Thank you, Carlos.
Yeah, really, I think, you know, the drag and drop, it is a nice feature. So it makes it a bit more user-friendly, right?
Yeah, drag and drop is really good in that specific scenario where you have one device. The platform really offers more because, yeah, you can do that for one device, but you have thousands of devices. You need rollout campaign management system. That's a completely different chapter, but you can pretty much show that here's how I start, and then when you need to scale, you're already using a platform that is ready to go and deliver thousands of big updates. So we could deliver 1 GB Android updates to devices to really 10,000 devices at ease. Let's go back to the Toradex hardware and which kits the EADT supports. We support the i.MX 95 series in the variants available, and we support most of the i.MX 8 series, whether it is Verdin, Colibri, or Palace. For the platforms that are not supported, just please submit a request, and we will follow up with you. Now, this is just the EADT, so the kit that is helping developers start as soon as possible. But as we will see later, if you have a custom hardware or you want to go and do a product, that's where custom builds comes into play. So let's have a quick look at the product lifecycle. So when you create a product, we have kind of 3 phases. We have called them the enablement, deployment, and support phases. So at the very beginning, as I already said, you want to create a proof of concept as quickly as possible. So you want to start prototyping and developing your product very, very quickly. But then even when you get to production, and then when the product is ready to go on the market, the job is not complete. You need to keep supporting your device. So you need a maintenance phase until the product goes end of life. So for that, you need to keep track of the software bill of materials. So which software is part of your of your operating system or your application, because then you may need to analyze, am I affected by security vulnerabilities? If so, do those vulnerabilities apply to my product? And if that's the case, you may have to create and deploy an update to your device. Again, updates don't apply just to security fixes, but you may have a new feature that you want to deploy to customer devices. So let's quickly talk about the enablement phase. So once you kind of select an SoC, you want to have a set of software tools that help you develop your product in a quick manner. We already talked about having an embedded Android OS for your kit. You can use the libraries that we mentioned. They will be integrated in Android Studio, and you can receive software updates. We show that all that part in the video. What we didn't say is that if you need a custom hardware integrated as part of the EADT, because you maybe have a custom display or have a specific sensor that it needs to be part of your development life cycle, then we provide them this kind of development as part of the EADT custom modules. When it comes to going towards the production phase, we start creating custom operating system builds. So we prepare what was initially done just for the dev kit. We adapt that to your hardware kit. We run your application in a kiosk mode. So you cannot get out of your application or only in a controlled manner. We fine-tune the security features exactly to the needs of your product. And if needed, we also provide manufacturing tools that maybe are needed during the assembly lines to check whether all the pieces of a hardware kit are working correctly. We already mentioned the SBOM and CVE tracking. Towards the end of the product development, you really need start tracking the software bill of materials and what comes with it. Okay, now we will have another couple of polls. The first one is about which kind of custom hardware goes with the Toradex SOM, especially for the carrier board. Are you using the Toradex carrier board just for evaluation purposes? I want to try this SoC and get that SOM. Do you use the Toradex carrier board as a start, but then design your own, so you come up with a custom carrier board? Or are you going to use the Toradex carrier board also in the final product, so both the SOM and the carrier comes from Toradex? The last option is you may need to come up with your own design in certain situations, so that's an option as well.
Good, and I think here we are allowing multiple answers. So we have people actually using the Toradex carrier board for evaluation purpose, plus prototype, plus carrier board. But it kind of, I think it is a good, kind of a good distribution of what we see actually among our customers. So 60% said that they had their own custom carrier board, which kind of makes sense. They kind of follow the same flows. I think most people they actually do the evaluation with Toradex, and a big chunk of them they will end up building their own custom carrier board. That is relatively common.
Exactly, and that when custom builds come into play, so you need a custom Android for your specific hardware. Then we see, for example, here that we have custom builds available for any Toradex SOM, because more often than not, when you go towards creating a product, you develop your own custom carrier board. So when customers move towards the second phase of the development, we do provide custom builds for that hardware. The last poll is asking you which kind of SBOM tracking you do. So the first option is you manage everything in-house, the SBOM tracking and also the generation of the updates. Another option is you rely on third-party services for SBOM tracking, but do software updates on your own. The third one is actually when SBOM tracking and software updates are delegated to a third party. And the last two options is when you are not doing SBOM tracking yet, you may not need that at all, but you may also think about doing that in the future because it's going to be important very, very soon.
And I think this outcome, it is quite, I mean, I wouldn't say surprising. I think it is actually what is the current state of affairs, because especially with the Cybersecurity Act, especially in the European Union, you see people, they are not doing it yet, but they know they have to, right? So this is coming, and they are aware of it, right?
Exactly. So for the support phase, we just mentioned CRA is going to be ever more important to track the software bill of materials. So Android as an operating system produces that list of software that is part of the operating system, but you need to analyze that. So you need a SBOM analyzing tool that will provide you with a list of CVEs that are affecting your product, and then that can be used to then decide to apply software update. For not connected devices, you could think of applying updates over USB. We have a USB Android updater tool for customers that have disconnected devices, but for those that for the devices that are connected, we recommend Update Factory, which is an over-the-air updates and device management platform, because again, we already talked about rolling out updates to thousands of devices. You cannot really go and do that one by one. So just a quick recap before we get to the questions. We support different SoCs. Just to mention two, NXP and TY are the most important ones. We support both SOMs and single board computers. And again, the first phase will be centered towards starting as quickly as possible. So it is important to have an Android build, an embedded SDK, and a ready-made solution for delivering over-the-air updates, and maybe small pieces of customized EADT modules for supporting displays or sensors or any kind of custom hardware. But when you go towards production, you need also other tools that help you in the support phase. So again, SBOM analysis and customized OSs are needed in this phase when you often go towards using a custom Android build. Okay, I've prepared a list of the main links that are useful. The Kynetics Toradex partner page, our YouTube channels, and other forums and resources that are useful if you want to start evaluating embedded Android for your devices.
Great.
Now we say we're ready for the Q&A session.
Yeah, thank you so much, Diego. It was a really instructive session. I learned a lot. I do actually come from an Android background, and I remember actually when I started at Toradex, I got this question about Android and Linux, and they clarified actually Android is Linux. So it's very close to my heart actually, everything related to Android. So let's actually go through the Q&A. There are a bunch of questions that came through, and maybe we start with one that is the last topic that we just touched on the presentation, which is CVEs, like common vulnerabilities and exploitations. So the question is about how the update factory handle CVEs, specifically if you also offer monitoring of Android apps. I guess it's like it's only the operating system or also the applications that you install.
Yeah, it's the CVE and SBOM tracking is not strictly part of the update factory. It's a separate tool that complements update factory. Yes, it does support both Android OS and applications. The main consideration here is that the input is an SBOM, so your build system is in charge of generating a software bill of materials that is kind of the list of the software that is included, and that will be the input for the SBOM analyzing tool, which will, depending on the version of the software, tell you which CVEs apply to your software. Then there's a second phase of checking whether those CVEs apply to your case, because maybe I don't know, it's a USB security issue, but your device does not have USB or USB is not exposed. Then you don't need to care about that CVE. When talking about Android applications, yes, sure. There are Gradle plugins that provide you the SBOM. So it's a library that you need to integrate as part of your build system. You will have the SBOM, and that SBOM will again be the input to the SBOM tracking and analyzing tool.
Mm-hmm. So maybe just actually this is my question is more about the threat model. So do you as basically the developer, your customer, does it actually decide what are the CVEs that they should be addressing, or is that taken care of? I mean, who does that? Who does actually who makes the decision about the I guess the severity of these CVEs?
Yeah. So the first phase is automatic, as we said. So you get you start from the list of software that gets analyzed automatically, and then also you get the level of severity of the CVE. But then there's a manual process. It can be done by the customer itself. So, for example, if it's their application, they need to be aware, for example, if a library is affected by a CVE, they need to spend the time to have a look. For example, I'm not using the part of the code that is affected by the CVE. So I'm using a library, but the vulnerability is in a part of the code that I don't actually use. It's a function that I don't use. Then you can mark that as not affecting my product, but you need to be aware of the use cases. So if you're going to analyze, if it's going the customer that analyzes their own application, that is part of their job.
Mm-hmm. Yeah, makes sense. Good, thanks. All right, so another question is that does the EADT integrate with standard Android Studio tooling?
Oh, yes, it does. I think I mentioned very quickly, but the EADT embedded SDKs are provided as a Maven repository. For those that are familiar with Gradle development, it's the standard way that Java and Kotlin libraries are provided. So we provide the repository, we provide the credentials to access that repository, and the integration in Android Studio is really quick, because once you set up the build Gradle, it's just a matter of specifying the library as any other library that is publicly available, for example, from Maven Central. As part of the Maven repository, we also do provide reference example applications. So when you start developing using a library, you also want to know how to use that code. Part of adopting a new library is actually reading the documentation, so reading the API documentation. But it's easier if you have a reference example, so an application that is already doing oftentimes the same kind of things that you're going to do in your own application, and you can maybe use that as a starting point. So maybe use a serial port. How do I open the serial port? Yes, okay, I can read the SDK documentation, but it's easier if I have already an application, I can see that running on my device, and then I have the source code, I can browse the source code in Android Studio, and oh, that's how it's done.
Good. All right, thanks for the very comprehensive answer. So thanks so much. So I think that's it when it comes to questions for today. So I would just like to thank you everyone for joining. Obviously, thank you especially Diego for the very informative session. We appreciate your time and your attention, and really looking forward to more sessions. We actually run webinars quite often, so keep an eye out for this type of webinars in the future. And yeah, thanks Diego. Have a great weekend, everyone, and see you next time.
Thank you. Bye bye.
Bye bye.